Hello students, now I will discuss more about that refractive index and more example I shall tell about that refractive index. All of you look at the board. Now refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1 by speed of light in medium 2. If you will read the refractive index of medium 2 with respect to medium 1, that is equal to the speed of light in medium 1 by the speed of light in medium 2, that is equal to V1 by V2. What is V1? The speed of light in medium 1 is V1. The speed of light in medium 2 is V2. That we can write that C by V2 whole by C by V1. C means the speed of light in air or vacuum. So that is equal to mu2 by mu1, where mu1 and mu2 are the refractive index of medium 1 and medium 2. One example I am saying. Suppose the refractive index of glass with respect to water, that we can write the speed of light in water by the speed of light in glass. That is equal to 2.25 into 10 to the power 8 by 2 into 10 to the power 8. Then 10 to the power 8, 10 to the power 8 cancel. 2.25 divided by 2, 1.125. As I already told you, refractive index has no unit. Similarly, you can say other formula also, or other way you can say like this: the refractive index of glass with respect to water is equal to refractive index of glass by refractive index of water. It is one more way you can explain also, or you can write also. So what is the refractive index of glass? 3 by 2. What is the refractive index of water? 4 by 3. So 3 by 2 by 4 by 3, that is 9 by 8 or 1.125. So in this way we can explain more and more about the refractive index. Now we will read about the effect on speed, that is V, wavelength lambda and the frequency f. Now come to once again, if a ray of light travel from rarer medium to denser medium, we know that the speed of light decreases. At the same time, the refractive index the wavelength also decreases. Remember, the wavelength also decreases. If the light travel from denser medium to rarer medium, the speed of light becomes faster. At the same time, the wavelength also becomes more. Thus, we can say that the speed of light V and wavelength lambda and frequency, how they are related, remember. But frequency does not change because the frequency depends upon the source of light. Thus we can say V is equal to f lambda. What is V? The speeds in that medium, the speed of light in the given medium, that is V. What is f? Frequency. What is lambda? Wavelength. Thus we can say f is equal to V by lambda. Now I shall tell you the relationship between the wavelength in the two medium. In the two medium means when a ray of light of frequency f and wavelength lambda suffers refraction from air to the given medium. Now look at here. If f is the frequency and c is the speed of light in air or vacuum, lambda is the wavelength, we know that f is equal to c by lambda in air. But in a medium, frequency does not change. In a medium, frequency does not change, but wavelength changes. So we can say f is equal to v by lambda dash. Once again I am saying you, lambda is the wavelength in air. I mean wavelength of light in air. Here wavelength of light in given medium, or which medium light passes, air to that given medium. So f is equal to v by lambda dash. Since frequency does not change, frequency remains same. So you can say c by lambda is equal to v by lambda dash. Look at here, c by lambda is equal to v by lambda dash. If we make lambda dash the subject, so lambda dash is equal to v by c into lambda. But we know that c by v is equal to mu. What is c? Speed of light in air or vacuum. What is v? Speed of light in the given medium. So c by v is equal to mu. So v by c you can write 1 by c by v, or lambda dash is equal to lambda by mu. V by C is equal to 1 by mu. What is V by C? 1 by mu. So lambda dash is equal to lambda by mu. Now factors affecting the refractive index of a medium. So there are three factors. There are three factors depend on the refractive index of a medium. So what are the three factors? Number 1, nature of the medium. Number 2, physical condition such as temperature. Number 3, color or wavelength of light. So first, nature of the medium. How refractive index depend upon nature of the medium. You remember, already I have told you, if the speed of light is more, then the refractive index would be less. Similarly, if the speed of light is less, then the refractive index will be more. Thus it is inversely proportional. Clear all? Now come to second point, that is physical condition such as temperature. We know that when the temperature will be increased, the speed of medium will be increased. This means with increase in temperature, the speed of light in medium increases. So the refractive index of medium decreases. Why? If the speed of light and refractive index, they are inversely proportional. Naturally, if the temperature will be more, the speed of light will be more. If the speed of light will be more, thus the refractive index will be less. It is also inversely proportional. I mean, the refractive index is inversely proportional to the temperature. Then come to color or wavelength of light. Remember, we know that there are 7 colors in a spectrum. Vibgor, violet, indigo, blue, you know this all, V2R. So out of them, out of the 7 colors, violet has maximum refractive index and the red has the least refractive index. Similarly, we know that the violet color has the less wavelength and the red color has maximum wavelength. So we can say that wavelength and refractive index, they are also inversely proportional. This means the color who has maximum refractive index has the least wavelength. Similarly, the color which has least wavelength has the maximum refractive index. For example, violet color has maximum refractive index and least wavelength. Red color has maximum wavelength and least refractive index. Once again I am saying you, the wavelength increases with decreases in refractive index, or you can say the wavelength of visible light increases from violet to red, and so the refractive index of a medium decreases with increases in wavelength. This is also inversely proportional. So finally what you remember, the wavelength and refractive index, they are inversely proportional.